So I'm back again, I guess, huh? Another Code of the Streets video. You know, and I learned a lot. Making that first video. I learned a lot about communicating with my audience, and also what I want to get done. So, welcome back. What we're going to talk about today. First, let's start off with the idea, the basic core idea. As a programmer, I realize I'm the creator of worlds. Anything I imagine, I can create. You know, you're going to see a lot of different things here. A lot of different ways that we express creativity in these videos. And I also want you to know that the programmer creates worlds and the programmer destroys worlds. That power is within your hands. Let's get started.
Shall we?
So the last thing that we talked about was the terminal. Yes. The last thing we talked about was the terminal. Right. And why did I bring up the terminal? Well, I brought the terminal up because what the terminal is a user interface. What's a UI? Or a user interface. Alright, so sometimes you'll hear people walking around like, computer's nothing but a collection of zeros and ones, on and off bits, wires with charges or lack of charges. That's all it is. But what does that really mean? What are you doing? Are you reaching in and you're grabbing wires and putting charges on those wires? No. And how does that even help you understand what a computer is doing, besides the fact that it is storing information? It doesn't. That's the answer. It doesn't. So it's true, yes, a computer is a device that's storing either electricity or a lack of it in some component on the system. And that collection of zeros and ones is what makes a computer go. But we can't work with that abstraction. That's not something that a human mind can even fathom or begin to manipulate effectively for the programs that you use on a daily basis. So what painstakingly occurred over years was the development of user interfaces. So eventually we got to the point where you have your personal PC, a little mouse there, and that PC, in its window, you could open up a terminal. And that terminal, sometimes you'd expand to fill the whole window, in which case you got your little dot to start to talk to the computer. So when you want to talk to a computer, you type in some text, right? Hello. And sometimes, the computer might want to say something back, and so it might say something back like, hello world. Because the computer's here, he wants to say hi, man. He's a friendly computer, he's not some asshole. He's a good guy, he's a robot, that's all. He's just... So, how is he going to say hello world? He can't say it in zeros and ones. he could try, and I don't know if this is actually what hello world would be in zeros and ones. We can find out, but it's not worth it. That's my point. Or he could build a terminal out of zeros and ones, and then inside that terminal he could say things and translate them from the zeros and ones into strings. So let's let this be the non-rambling side over here. And we're gonna put strings. And what are strings? Collections of characters. Have a binary representation that a computer understands. Code of the streets, code of the streets. Who's colder than me? Colder than me. Gotta get your marketing in it right, you know what I mean? I gotta remind you why I'm here and who I'm here to help. So, a couple things here. What is binary? You need to know that also. So binary, 0 and 1 representation of, you could say information even. Let's go with information. Let's keep it broad. 0 and 1 representation of information. 0 and 1 representation of state. Yes or no. Binary. You can use it in math. You can use it in logic. So, computer understands binary. It also translates the binary into strings, and then those strings pop out in your user interface as a communication. So it goes from being silent to saying hello world. So why am I bringing this up? I'm bringing it up because in your whiteboarding challenge, everything is based on understanding. In your programming journey, everything is based on understanding how to take information, an idea, put it into the computer, and then pull it back out. But there's two collections of problems that reflect the terminal interface, and then problems that reflect an understanding of the graphic user interface. And so you have to understand that a certain collection of algorithmic challenges are going to reflect a period of time where the terminal was king, where strings, collections of characters that have a binary representation that a computer understands, that those are the core, that understanding is the core of solving those challenges, where you're just dealing with a line with the manipulation of these characters. basically. That's in the algebraic and numerical ways that you're accustomed to doing using logic in life. And then also parsing information. One of the questions that you have to begin to master as a person that works with algorithms is the concept of the creation of an invisible instance of an object as a collection of properties, ways to describe it. For instance, what makes what makes a robot a robot? Right? What makes a robot? Right. So I would say AI brain. 2. I'm gonna say limbs. I'm gonna say body core. Right? I'm gonna say I'm gonna say AI brain, limbs, and a body core. So, and that could be within that. So I mean, basically, you have a shape of some sort, and you have some type of limbs, nodes that can interact with the world in some way. Might be able to make a robot that does nothing but stand, and the AI is on the inside, right? Why not? Why not just put some cameras on this thing and it's moving around, right? You want to add a third limb for stability. Can't see the foot back there, but it's there. So what you do when you're talking to a computer in strings, and when you're solving algorithmic challenges, is you assign meaning to variables. Sometimes you're creating classes of objects, sometimes you're creating the properties of an instance of the class, but you are assigning value to whatever it is that you imagine. If this is my robot and I want to start describing it to the computer, I would basically start talking to the computer. Like I might say that I have a class of type robot, right? And I'm gonna start telling the class that brain is true. Limbs is equal to 3. And core yeah. Core let's let's say core is equal to 1 in my design, because I just had an idea. What if I go like this? And my robot is now made of a partnership with another robot. They both have 3 limbs. And I could change the value of core. When I create an instance of this class of robot. So what I really want to do is start to introduce you to the concept of a way to draw what it is you're creating in these classes, because they're invisible objects, and unless you begin to create models of those invisible objects, it's going to be hard to then begin to describe the properties of the invisible objects as class objects in a programming language. Creating models is the core of programming. You know, Tony Stark knows how to draw. So, let's say we create this class robot, 2 cores, and we want to describe that to our computer. How do we do that? Well, we don't do this. We don't start writing zeros and ones and ones and ones and zeros and zeros and zeros and ones. We don't do it that way. This might equal, I really don't know, but I mean it could equal a character H. And so you take another one and you zeros and ones, 1, 0, 1, 1, no twos. This is binary. Binary is nothing but a collection of 0 and 1s, blah, 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 blah. That could equal E. I don't know what the real values are, but that's how the computer starts to understand that you're saying hello world, or you're saying class robot. Make one with these properties. Those zeros and ones translate into what you see before you there, and now the computer starts to store what you're abstracting down very quickly, right? This complex physical object you're abstracting down to a very simple collection of properties, and that's how programming works. Because once you start filling out the properties, and people work in teams to fill out the properties over years, then certain objects get created. And those objects are what's used to allow you to communicate in effective ways. So what did the terminal lead to? The terminal led to the graphic user interface. Everybody wants to know why Steve Jobs is considered the wizard. Outside of what he created later, what was the first explosion? What was the big thing the big idea. And the big idea that he got was the GUI. He understood that nobody wanted to talk exclusively to a computer using this. That I just broke the rule. And the rule we talked about in the first video is always record your data. And that you want to do that every time you whiteboard something. Just make it a rule to take out your phone and take a picture. Plus I gotta turn these to NFTs later, you know what I mean? Boy. Code of the streets, code of the streets. Who's colder than me? Colder than me. Turn these things to NFTs and get that cheese. We MCs plus degrees. Yeah. So really what we want to do now is we want to talk about the GUI. And now think about it. The way that the computer understands how to communicate with us up until this point is nothing but strings of characters. Nothing but strings of characters. But then the computer gets the bright idea that it's like, look, I keep saying these things. I keep saying hello. You know? Hello, world. Hello, world. And nobody's listening. Nobody's listening. Maybe I can present this information quicker. Maybe I can present this information using pictures. What Jobs really does is he gives you the desktop. That's really what Jobs does. He gives you the desktop because until when suddenly you can look at a bright screen layered in tabs that you can click and go places. You don't need to talk to the terminal, a little box here, and enter memorized commands, right? When you don't have to do that anymore, right? But you can click and go where you want to go. Not with any one of the programs that are in the past, you had to remember. You had to remember the names of your files. You had to enter that information in here, the names of your files. Otherwise, you couldn't see them. There was no way to get to them. This allowed people using a mouse to point and click. Point and click. And open. And drag, right? And delete. Right. You could move things around in your computer without having to type. Delete. Know the name of the file, my file, and its location / I don't know. Right? Who has time for that? Anybody had that pleasure? You know what a treat the command line and the terminal is. Code of the streets, code of the streets. Rise of the matrix, see sharp from basic. These sharks are dangerous, these broads are brainless. It's time for changes. Iraq enraged us. Strap up your laces. Here come the Masons. So now you have these icons that you can use. You can slide around on the board. You can move your files, your programs. If you want to see them, you can bring them out. He brought the computer to life. Now there's also, think about the algorithms. There's a certain class of algorithms that involve the motion of objects, maps, graphs, collections of objects, data structures. That's a generation of programming problems, algorithms that you're going to have to understand. Questions about linked lists and sets. One of the ways to address this challenge is to use pseudocode. You'll hear talk of pseudocode, including basically having its own, you're having your own system. It's very useful. But the best thing to do, and what this video series is actually really becoming about, is just the whiteboarding freestyling process. You see on YouTube some guy walk out and start writing complex code. You got perfect braces. You know what I mean? Like look. If you're writing like a recursive hammer of God, right? Like I don't want to see that in these videos, you know. I mean, for here, the for loop, the I is equal to 0, I is not equal to 0, I is less than array dot length minus 1, you know, and you're not explaining what the hell is going on or where that stuff is coming from. That's not the algorithm. That's not the algorithm. Right, the algorithm is actually an understanding of the problem. And that is what we're going to work on in these videos. So I want you to remember, there were 2 time periods. Yeah, there I deleted them. I'm always going to delete. I will delete. And the NFT, I mean, I just cut the image out, right? It's crazy. NFTs, by the way, the blockchain, that's where we're going. That's part of what we're going to work our way up to in some of these videos. We're going to be doing some blockchain stuff. Maybe I'll just present what I learn as I learn it, and actually, because this is just freestyle. But I think I taught you some good shit. I want you to remember that there are 2 time periods when you start looking at these problems. The 60s to the 80s, you know, command line. String manipulation. Matrices. Numerical calculations, you know. Right. This is all before the explosion of object-oriented programming. Java didn't exist. Right. Okay. There's a collection of algorithmic challenges and written for a time before Java existed. And then until now. GUIs, graphic user interfaces, graphics using images, basically the idea of the card as the file, the card as the folder, the card is something that icon that you can click on, interact with, right click on, have a menu of options. GUIs. OOP. Right? A new collection of algorithms that weren't based in strings, in databases, and by databases I mean think spreadsheets, long lists of strings and numbers, just funneling out of corporate machines like 80s stock paper printout, I gotta get these numbers right, Johnson. Right? That's what the 60s to the 80s were. The 90s until now involve graphic user interfaces, object-oriented programming, and the data structures. And so the manipulation involves data structures. You're moving around much more complex collections of objects, yeah, and so then you're talking about linked list. You're talking about sets. You're talking about maps. Right. The algorithmic questions reflect the existence of Java. And now other languages too, like Python, which I've glanced at, but I don't know any. Actually, and that brings up part of the point of these videos, and we'll begin to hammer this down, is my journey is headed in the direction of Java. So some of the things that I'll be working on or will be using the syntax of Java. Some of the pseudocode I'm going to try to reflect the Java language, but the language that I'm most familiar with is JavaScript, and we might have some discussions about that. We will. We're going to talk. Yeah, we're going to talk about that. We're going to talk about why I started using JavaScript, what my original purpose was, how I think it can help you guys in the future. Yeah, but I think this one is done. I'm learning. Each one of these is going to have a different feel, but I'm going to keep it real the whole time. Yeah, we're going to have a blast. Code of the streets. Code of the streets.